Welcome to this session. In the previous session we have discussed some rules to find nature of roots of a quadratic equation by using discriminant. In this session we can apply those rules to some quadratic equations. So what is the discriminant here? That is delta is equal to b square minus 4ac. This is discriminant when the quadratic equation is ax square plus bx plus c is equal to 0 and a not equal to 0. Here a is the coefficient of a variable and b is the coefficient of variable x and c is a constant here. Okay, this is the discriminant. By using this discriminant we can determine the nature of roots of any quadratic equation. Okay, so consider one example, that is 1. In a quadratic equation ax square plus bx plus c is equal to 0. So this is given quadratic equation ax square plus bx plus c is equal to 0. So in this quadratic equation, if a is equal to 0, then what will be happen? Then what is the equation? If a is equal to 0, that means you have to substitute this value in a, that is 0 into x square, this term. So the 0 into x square is equal to 0. A total term is become 0. So then the remaining equation is bx plus c is equal to 0. So what is this equation? This is linear equation. This is linear equation. So if in the quadratic equation if a is equal to 0, then it becomes a linear equation. It's not a quadratic equation. Not quadratic equation. This is important condition for quadratic equation. That is, if it is becomes a quadratic equation, a not equal to 0. This is one condition. Next, we will discuss another example. In a quadratic equation, x square plus 2x plus 1 is equal to 0. It is a quadratic equation. For this quadratic equation, what is the nature of roots? This is given quadratic equation x square plus 2x plus 1 is equal to 0. If you compare to the standard form of quadratic equation, then what is the values of coefficient? A is equal to 1. This is 1, and b is equal to 2, and c is equal to 1. So these are the values of coefficients and constant in the given quadratic equation. So now what is the discriminant? The formula is delta is equal to b square minus 4ac. If you substitute those values, that is b is equal to 2 square minus 4. Here what is the value of a is equal to 1 and c is equal to 1. Now 2 square is equal to 4 and 4 into 1 4 and 4 into 1 4, that is equal to 4. So 4 minus 4 is equal to 0. Here the discriminant is 0. So according to the rules, if your discriminant is 0, then the nature of the roots is real and equal. Okay, so in this equation, for this quadratic equation, the nature of the roots is real and equal. So by using discriminant we can find the nature of roots of a quadratic equation. If the quadratic equation 3x square minus 10x plus 3 is equal to 0, then the nature of the roots is dash. So by using discriminant we can find the nature of the roots, that is equal to b square, delta is equal to b square minus 4ac. When you compare to this equation with the standard form of a quadratic equation, the value of a is equal to 3 here. In this quadratic equation, value of a, the coefficient of x square is equal to 3. Here b is the coefficient of x. Here the coefficient of x is minus 10, that is equal to b is equal to minus 10, and the constant c is equal to 3 here. Therefore that is equal to c is equal to 3. Substitute these values in the discriminant formula, that is delta is equal to b square. What is b square? Minus 10 whole square minus 4. What is a value? That is 3, and c value is 3. Minus 10 whole square. Minus 10 into minus 10, that is 100. Minus 4 into 3, 12. 4 3s are 12. 12 3s are 36. That is equal to 64. Therefore delta discriminant is equal to 64. it is greater than 0 and it is a perfect square. It is a perfect square. So by using this condition, when discriminant is greater than 0 and it is a perfect square, then the roots are rational and unequal. The roots are rational and unequal. This is the nature of the roots for the given quadratic equation. In the same way, if discriminant is greater than 0, not a perfect square, then what is the roots? Nature of the roots? That is irrational and unequal. This is the note. So in this way, by using discriminant, we can find the nature of roots of a quadratic equation.